Okay, in this video we're going to be working with quadratics. Section 1.4 is solving quadratics using factoring and using the quadratic formula. In this video we're just going to focus on the factoring method. So we are going to start with this example. Solve by factoring 2x plus 1 times 3x minus 4 equals 0. In order to do this, we need to remember there's a couple of rules that we need here. One is called the zero product property, and it just states that if you're multiplying any two numbers together and the answer is 0, then one of those original factors has to be 0. So let's say if you're just doing a times b equals 0, then that means a equals 0 or b equals 0. Okay? So in this first example, we can see that we're multiplying this 2x plus 1 factor with this 3x minus 4 factor, and that product is 0. So that means that one of these original factors has to be equal to 0. So we're going to say 2x plus 1 equals 0, or 3x minus 4 equals 0. Okay, since they're being multiplied and their answer is 0, then one of them has to be 0. And then solve each one for x. So 2x equals negative 1, divide by 2. X equals negative 1/2 is one possible answer. And then in the second one, add 4 to both sides. So 3x equals 4, divide both sides by 3. X equals 4/3. And it's not unusual for you to get two answers in these types of problems. So we get x equal negative 1/2, x equal 4/3. In number 2, we have x times 3x plus 9 equals 0. So the two factors are the x and the 3x plus 9. So we set each of those to 0 and solve. So x equals 0, or 3x plus 9 equals 0. So here you subtract 9 on both sides. 3x equals negative 9. Divide by 3. X equals negative 3. So x equals 0 or x equals negative 3. In number 3, let's add 121 to both sides first, because in order to do this time it's not set to 0. So we need to first generally, when you solve by factoring, you'll make sure that you're in this what we call standard form, where you've got the entire equation equal to 0 on one side. Okay, so ax squared plus bx plus c equals 0, and then we factor it, and that would get us to where we were already in the first question, where it was already factored and equal to 0. In number 3, it's not equal to 0, so our first step is to get everything on one side and set it to 0. So add 121 to both sides, or you can add x squared. I'm going to add x squared to both sides because I don't want the x squared term to be negative. So now I have 0 equals x squared minus 121. Okay? X squared minus 121, I recognize 121 as a perfect square. Okay? Since 121 is a perfect square, it's 11 square, then I can, and this is being subtracted, I can use my difference of squares formula on this. So a is x and b is 11, so this will factor as x minus 11 times x plus 11. Now I've got it factored, and it's equal to 0, so I set each of my factors to 0. So I have x equals x minus 11, or 0 equals x plus 11. So x equals 11, or subtract 11 on both sides, x equals negative 11. 11 and negative 11 are my answers there. Let's go to another one. Number 4. 5x squared plus 32x equals negative 28x. So I'm going to start by adding the 28x to both sides. 5x squared plus 60x equals 0. And then I can factor, I need to factor this, so I'm going to pull out 5x from each term. That leaves x plus 12 equals 0. And then set the two factors to 0. 5x equals 0 or x plus 12 equals 0. Divide by 5. X equals 0 or x equals negative 12. Number 5. The product of two consecutive negative integers is 1,122. What are the numbers? Alright, so consecutive just means that they're one after the next. So examples of consecutive integers would be 4 and 5, 9 and 10, 15 and 16. These need to be negative, okay? But and they're integers, so that just means that they are not fractions or decimals. So in this one, I'm going to let x equal my first integer. If it's consecutive, then the second integer can be represented by x plus 1. Okay? And it says that their product is 1,122. So that means that if I multiply x times x plus 1, it should be equal to 1,122. Okay? So I now need to work on getting this in my standard form so that it's all equal to 0. So I'm going to distribute. I've got x squared plus x equals 1122. Subtract 1122 on both sides. Got carried away there with my 2's. So x squared plus x minus 1122 equals 0. And then I start looking at how I can get this to factor. So I know I want to do the 1 here times 1122, and I want to look at all ways that I can get all the pairs of numbers that I can use to factor this thing. Okay. Now with this number being so large, it might take quite a while to find the right pair of numbers. Okay, so as I'm beginning, I see that these numbers are awfully big. I can continue with this and I will find the right pair of numbers. However, on your graphing calculator, if you've got your graphing calculator, you can speed up this process. I can go to my y equals button. I'm going to clear out anything that I already have in there. This number, 1122, I'm going to type it in. I'm going to divide by x. And then I'm going to go to second graph so I can see a table. These are all, no, the decimals I'm not interested in. I'm interested in whole numbers in my y column. So if I scroll up and down this thing, I should find some numbers like 22 and 51 would be in this list. 17 and 66. (11 and 102). Okay, they're not in order anymore. But if I keep looking, remember you're trying to find the pair that you can add or subtract to give you. In this case, you need to get a 1. Okay, so I'm trying to get 1 when I add or subtract these together, and so far I don't have what I need. So I'm going to keep looking up and down my list. There's a 33 and a 34. Okay, looks like that's what I need to get my 1. So if I do a negative 34 and a positive 33, no, it needs to be, I need to add them to get positive 1, so I want negative 33 and positive 34. Okay, so I can do the grouping method, pull out an X, and over here I can pull out 17 or maybe 34. Let's see, 22. Yeah, I could pull out 34, and that's going to give me 33. Okay. Alright, and I'm out of space. So, continuing, that gives me, I can pull out the x minus 33, and that leaves x plus 34 equals 0. So x equals 33, or x equals negative 34. Okay, now for this problem, remember they had to be negative integers, so I would go with a negative one, and then that would be my first integer. My second integer is negative 34 plus 1, and that would be negative 33. So my numbers are negative 34, negative 33. Negative 34, negative 33. Number 6. The width of a rectangle is x plus 1 and the length is x minus 6. What is the length and width of the rectangle if the area is 30 feet? Okay, so here's my rectangle. It's always good to draw a picture. My length is x minus 6. My width is x plus 1. And I have the area is 30 feet, so I know the area of a rectangle is length times width. So I can get my equation by saying 30 equals x plus 1 times x minus 6. Now I need to get this into the standard form, so 30 equals x squared minus 6x plus 1x is minus 5x minus 6. Subtract 30 on both sides, so that gives me 0 equal x squared minus 5x minus 36. And then can I factor this? Factors of 36 that I can use to give me 5, I could do 9 times 4. Okay, so if I go through and do my grouping method, I'm going to end up with x minus 9 times x plus 4. Set each of those factors to 0. So I'm getting x equals 9 or x equals negative 4. I cannot have a negative length or width. So if x is 9, then that means that my length, which was x minus 6, my length would be 9 minus 6, or 3, and the units are feet, 3 feet. My width is going to be 9 plus 1, so that's going to be 10 feet. And number 7. The area of a triangular lot is 225 square feet. The base of the lot is 7 more than its height. Find the length of the base and the height. So we've got a triangular shaped lot. The base is 7 more than the height, so I'm going to let x be my height. I'll call the height x. The base is 7 more than x, so x plus 7. I need the formula for area of a triangle. That's half the base times the height. And I'm given that the area is 225. So I've got 225 equals 1/2 times x plus 7 for the base times x for the height. And I need to solve this for x. So first, I see that I've got a denominator of 2. I'm going to multiply both sides by 2. So that'll be 450 equals, and then 2 times 1/2 is 1. So that just leaves x plus h times x. And I apparently have made a mistake here. I'm sorry. This should not be x plus h. My base was x plus 7. I don't know where I got my h from. My base was x plus 7. So I'm going to work on getting this into my standard form. So 450 equals x squared plus 7x. Now subtract 450 on both sides so it's equal to 0. 0 equals x squared plus 7x minus 450. And then I need to factor this. So I can go start looking at I can take the 1 times 450 is 450. 1 times 450, 2 times 225. I can keep going with that. And if it takes me a long time, or if I'm pressed for time, I can go to my calculator and clear out the previous equation. I went to y equals, and this time I'm trying to get my numbers to multiply to 450. So I'm going to say 450 divide by x, second graph to get to my table. And what number are we trying to get here? We're trying to get these numbers in this column. We're trying to find a pair of numbers that will add or subtract to give us the middle number 7. So if I go to my chart or my table and start scrolling up and down, I see 25 and 18. Okay, 25 minus 18 is 7. So I'm going to see if that will work. I'm going to choose that pair. Okay, and then I can do, I'm limited on space, but I can rewrite it with 4 terms, do the grouping method, and when I do that, I end up with x plus 25 times x minus 18. All right, so from here, some more paper. We've got 0 equals x plus 25. Or 0 equals x minus 18. So subtract 25 on both sides. Add 18 to both sides. We can't have a negative height because x was the height, so that's no good. So we're getting 18 for x. So that means my height is 18. These are in, what are the units? These are in feet. And my base is 18 plus 7, so that's 25 feet. It looks like I went off the page screen. There you go. Okay, so that's as far as that's most of the examples for the first half of section 1.4 dealing with solving using factoring. The next video I'll do some examples of solving using the quadratic formula.